Oh my God. This is by far the most frustrating machine I've ever worked on. Now that I'm back from vacation, I thought I'd do a quick Commodore 64 video before I get back to the massive challenge that the PET 4032 represents. I plan to quickly repair 5 Commodore 64s as part of my 4064s in 23 challenge, since 2023 is the 40th anniversary of getting my very first computer, a Commodore 64, of course. This will also make for a simple video to edit because I'm still getting used to the new software. Since this video changed gears along the way several times, I, Future Mike, will be here to help you make sense of things. You'll be able to recognize me by the time machine on my shirt. Little did I know that the first machine I grabbed, totally at random, had more problems than I have ever dealt with on a Commodore 64 before. I've never met a Commodore 64 I couldn't fix, so hopefully we can get this one working and I can keep my record intact. First machine from CM250 School District 4J with a property tag. So in these early shots, I still thought I was going to be doing 5 machines. So when I talk about machine number 1, just understand that machine number 1 has more than enough problems for an entire video. Her up, turn her on, get a black screen. One important thing to note here is that I'm using a bench power supply with an overvolt protector on it. When you're repairing a Commodore 64, or really any machine, make sure that the power supply you're using is good before you use it. The Commodore 64 power supply is well known for putting out too much voltage on the 5-volt line, which can cause massive damage to a machine. I think that's something we're going to learn about right here. Ooh, foreshadowing. All right, let's take in, see what's inside number 1. Screws are very crusty. Ooh, there's a bit of mold matted in the corner. Got some crusty bits there and there. Keyboard, I will clean off camera. Same with the case. Looks like we have all of our chips in place. Everything is soldered except for the SID. This is a 250407. All right, so a couple things I'm seeing here. I think that is the first time I have ever seen a leaking capacitor in a Commodore 64, but this machine was stored in a very, very nasty manner. So this machine's gonna have to be recapped. I'm also noticing on the SID over here, got some corrosion on the pins. Bottom shield loose, so let's see what's under here. There's a lot of flux on that board. Here you can see it. So these are Oki RAMs, which is a good sign. See how rusty that's gotten. Nasty, nasty. So here I decided that since the VIC-2 graphics chip is socketed, I'd go ahead and test it in the ZIF64 to eliminate it as a problem. Testing the VIC-2 to see what happens here. So, and it looks good. So I think we got a good VIC. That's good. I don't want to have to replace a bunch of VICs. One often overrated piece of test equipment is your senses. A visual inspection of the board already identified a problem with the capacitor and with corrosion on a couple of the SID pins. Now I'm testing the temperature of the ICs by touch. Of course, a fancy thermal camera would be a lot easier, but I don't have that piece of equipment, and I think all of us can test by feel. So right after power up, I check the chips for extreme heating. Then I give the machine a minute or 2 to warm up, and then I go ahead and check them again. And here I found that U21, which is a RAM chip, was really baking, and U3, the basic ROM, was warmer than the other ROMs. So the next step on any repair is check the voltages. Got 5 volts there, 8.9 there, 7.5 there. That's the 5 volts for the VIC, but why? 12 volts is not right. So I think the first thing I'm going to do, since we got cap issues and the 12 volts isn't looking right, I'm going to go ahead and recap this. And I think we've all seen enough recapping of things that I don't need to do that on video. So here it is. Replace this capacitor because it was bad with capital B. So now on the input for the 12 volts, we turn it on first. So now on the input of the 12 volts, got 19.24. The output, we got 12.15. And then of course our 5 volts, we've got about 9, 5. Now this is the 5 volt can. It supplies power, if I remember right, to the SID and the VIC. So now I've got good 12 volts. I don't expect that's going to fix the problems, but we will find out here in just a second. And no surprise there, still a black screen. This RAM chip is definitely getting hot, which is one of the reasons why I thought we'd still have issues. I'm also going to need to replace these 2 sockets. They're terrible, and that one's got some corrosion in it. So after replacing the baking RAM chip, I was still getting a black screen, so I went ahead and pulled the basic ROM. After pulling the basic ROM, I'm still getting a black screen, so it's time for some more basic checks. When the system is first turned on, it takes a fraction of a second for the voltages to rise to acceptable levels. If the system were to try to run during this period, it would immediately crash due to the invalid voltages. To prevent this, there's a circuit that holds a system reset line low, or at about 0 volts for a fraction of a second. Then it goes to high, or about 5 volts, allowing the system to run. If this circuit doesn't hold the system in reset long enough, or never goes high, then the computer will never start doing anything. So that reset signal is on pin 40 of the CPU, and when we turn the system on, it stays low for about a half a second and then goes high. Let's slow that down a bit. Perfect. One specification you'll hear battered about the Commodore 64 is that it runs at 1 megahertz. This simply means that there's a signal in the machine that goes from 5 volts to 0 volts and back again 1,000,000 times a second. This signal tells the computer when to do things and kind of acts like a choreographer. This signal comes from the VIC chip, and I test it here on pin 1 of the CPU. And this definitely looks wrong. I actually ended up messing around with this thing for about an hour until I figured out that the problem was that contamination on the pin on the CPU was interfering with the oscilloscope connection. So as you can see here, it's just fine. Okay, we've checked the reset and we've checked the main clock. So now we need to check an alternative clock known as the phase 2 clock. Now this clock is 180 degrees out of phase with the system clock, simply meaning that when the system clock is high, the phase 2 clock is low and vice versa. This is used for memory and I/O operations. The main thing you need to know about this clock is if it's not working, the computer's not working. As you can see, the signal is right here on pin 39 of the CPU, and as ugly as it is working as intended. Okay, so at this point we know the system has power, it's not being held and reset, and it's got good clocks. Normally the next thing I would check is the address bus, but for some reason I went poking around on the data bus, and it was kind of interesting, so I'm going to show this here before I get on to what I should be doing. So starting off on the CPU, we're going to go with pin 37, which is D0, the data bus. We'll turn the power on. Okay, that's data bus 0, and that ain't right. Those levels are weird. So there's a wide variety of signals on these lines when the computer's operating normally. So what we need to look for is abnormal signals. Now, the main telltale that we're going to be looking for is signals that are hanging around between 1 volt and 4 volts. While the signals do have to go through these voltage levels, they shouldn't be hanging around there. We also don't usually expect to see these lines stuck high or low for any extended period of time when the computer's executing code. So I did a little bit more poking around, and it's a mess. So what I decided to do is I took a few days to just kind of ponder my next steps, and I reached out to some people asking if they had any suggestions on what I could do besides make a guess. Yeah, crickets. At least during that time, I did discover that I can hook my oscilloscope directly up to the network and capture it straight onto the computer.
So I got that going for me, which is nice.
In the end, I decided to change the PLA because it is by far the most common failure I see on Commodore 64s. Unfortunately, it did not cooperate with my desoldering. I had to cut some of the pins, so I wasn't able to test it afterwards in the ZIF64 to see if it works, but I'm pretty sure it was bad. So after changing the PLA, I still had a black screen, so I decided to do what I should have done in the first place and start taking a look at the address bus. So in the end, I found that I had as many bad lines on the address bus as I had good ones, with only 8 of the 16 lines having valid signals. So just to give you an idea, here's what a normal address line should look like. So here's the bad lines, and as you can see, they're completely different than what we were seeing in the good lines. Some of them are stuck high or mostly high, and some of them are just kind of bopping around and hanging around in that range that's not valid. These are usually caused by a faulty chip trying to keep a line high or low all the time, or by a chip that's just on the bus when it's not its turn. Take your turn, man. So for the last time on this project, I had to make an educated guess. So I tested the basic ROM that I had already removed in another machine, and it was actually working fine. Now something had to be making it hot, so I went ahead and removed the other 2 ROMs that are nearby in the circuit, and on top of that, you don't need to have any ROMs in the computer in order to run the dead test cartridge. So, win-win. So with all the ROMs out, I hooked up the dead test, and finally, I got the first signs of life out of this machine. With the dead test cartridge in, I get a single white flashing screen. Just one flash, flash, flash. But hey, it's something. So looking in the dead test manual, I find that a single flash indicates a bad RAM chip in position U12. So I changed that chip. So after changing U12, we're getting 2 flashes, which corresponds to IC U24, another RAM chip. So I changed it. And then we're getting 3 flashes, which corresponds to U11. So I changed to U11, and now I'm getting 4 flashes.
1, 2, 3, 4. Ha ha ha.
Okay, this is getting ridiculous. I know there's other chips on the board that translate address line signals to activate the correct RAM chips, so at this point I decided to change those out. And that's these 2 74LS 257s that are right next to the RAM. So I went ahead and desoldered both chips, put in sockets and replaced them, and what I got? It's exactly the same thing, still getting 4 flashes. So with the initial hot RAM chip I'd already changed out, I've already changed 5 of them. So I decided to go ahead and just change the other 3. So I pulled the other 3 RAM chips out and gave it another test. All right, so now that all the RAM is replaced, this is what we've got. Let's see what happens. Black screen still. Oh, well, we got something there. Interesting. All right. Well, we're making progress. Let's get out the scope and see where we're at. So I wanted to see where we were outside of the dead test environment. So I went ahead and put the 3 ROMs back in, and now I was at a black screen. So I did a little poking around, and this is with the kernel replaced. And sometimes the ROM's in it, the dead test out, I get a screen. Sometimes I don't. There we go. All right, making progress. So the next thing I did was I rechecked the address bus, and I found that all of the problems resolved except for 2. Address lines 6 and 7 were still invalid. So looking at the schematic, I decided the next thing to do would be to change the color ROM. So I pulled the color ROM just to check. I didn't think it was going to do it, and it did not. But I did that because it's connected to the address lines that are giving me trouble, which appear to me primarily A6 and A7. A12 is questionable. So looking here, they all go through U13. I've swapped the two RAM banks back and forth just in case some of my replacement RAM was bad, but it's fine. So next what I'm looking at here is, so here's the color ROM right here, and this is coming over, connecting up into the LS373. So even though those are labeled Q, they're actually tying into the address lines. So I'm going to try that one next. All right, replace the chip. Didn't have any difference, so I put it back in. So it's not much left. All right, so I think I may have found the solution. Looking at my notes, the problems I have are always with address lines 6 and 7. And I was looking on here, and I noticed that this 74LS258 right here, address lines 6 and 7 both go to it. And that is this chip right here. So I don't have any of those, but I was looking around and found on one of Carl's parts boards that there's one on here and it is socketed even. So no guarantee it works. Here's a parts board. All right, so now that the 74LS258 chip has been replaced, I was pretty confident that that was going to solve the issue because of the way only address lines 6 and 7, remember those are the ones giving me trouble, they're the only ones being routed up to this. So confidently, I hooked the dead test cartridge back up and gave it a test. Time for the moment of truth. Oh my God, this had better work. If this doesn't work, you might see a grown man cry. If it does work, you might see a grown man cry. And in 3, 2, 1, blast off. ROMs are in, no dead test. Okay, I got nothing. Nothing at all. Arrgh! Man, this thing is just so frustrating. What the hell's going on now? I'd pull out my hair if I had any. This machine was really toying with me. So what had happened is a video cable had come loose in the RetroTink connection, but was still stuck in the hole, so you couldn't tell it wasn't connected. So there was nothing wrong. So let's try that again with the dead test. In 3, 2, 1. So I think we got a problem with OBS again. Come on, OBS. If I deactivate and reactivate, hey, look at that. The frickin' OBS video source had hung. Really? Really? What the frack? The OBS input had crashed, so it looked like I wasn't getting any signal at all. So after I restarted the service, I got this. All right, so and dead test in 3, 2, 1. With OBS now working, with the RetroTink plugged in, I still see a black screen. Are we going to stay black screen? Oh, look at that! I see text. Checking 0 page. Okay. Stack page. Oh, look at that. So next, as soon as this is done with the pass, I will hook up all of the dongles and run a diag on it. Oh my God. This is by far the most frustrating machine I've ever worked on. All right. Now that I finally had a machine that could execute code all by itself it was time to move on from the dead test cartridge to the Diag cartridge. Dead test is just designed to get to this point where you got a running machine. Now the Diag cartridge is going to put it through its paces. At this point, I thought I was pretty much done, but this thing still had a few hoops for me to jump through. Let's take a look at the Diag results. So let's see what we get with a Diag. So again, I'm going to guess that the left CIA is bad. Not guessing, I can see that the clock's off on it, so that one's going to have to get pulled. And so running through there, we're showing all kinds of bad problems still. Serial ports, control ports, user ports, timers. 6526s, 6581, of course, is bad because it's not installed. So the next step, we're going to have to replace this CIA, which is a serial port in itself, and see what that fixes. But we're making progress. We're moving forward. And so much recording video. I've taken that 74-258 off. I said to hell with it and took off the CIA without shooting video. So of course it just came out beautifully and easily. Of course it's probably a bad chip, so wasted effort, but if they were all this easy, I'd never be cutting pins. Alright, so the 6526 has been removed. It's in the ZIF64, and as you can see, it's throwing most of the errors. Okay, so the CIA chip was bad, and it's been replaced, so let's give another final test. All right, final test. Put in a different SID and replace the CIA, have the Diag cartridge in. Let's see what we get. Please be good to me. I've had enough. Come on, baby. You can do it. I know you can. Come on. Hey, good control port. Good SID. And working sound. It's a little poppy, but I always get these same pops when I'm going through this capture device, so I think that's the cause. Everything seemed to be fine at first, but after a little while, the second CA started showing up as bad. So I desoldered it and I tried it in the ZIF64, and it seems to work fine. Since the user port, which is controlled by the CIA, was showing as bad, I decided to go ahead and clean the contacts, leading to yet another final test. Okay, now we're getting somewhere. I did return the original CPU to the board, but found that after a minute or so, it started crashing the machine, so it was also defective. The keyboard and case were cleaned up off camera. This machine ended up needing over a dozen ICs replaced, on top of being one of the rare Commodore 64s that actually needed a recap. Okay, so in the end, this machine, it needed a lot. I ended up replacing all of these parts, over a dozen chips, all the capacitors. It was a mess. And pretty clearly what had happened to this machine is it had been plugged into a defective power supply. So as you know, Commodore power supplies, they fry things. And according to the note, this happened in 1991. This machine has been dead since then. One of the things I didn't show in the video, but here I'll show you right now, is that the end of the board is literally splitting. So clearly it was getting a lot of water and the board's literally splitting. The ground plane's coming off on one end. So it's quite a mess. So now let's play some Moon Patrol. See how this does. This machine's running great. I ran over 1,400 cycles through the Diag cartridge, so it's been tested for, what was that, about 20 hours? It's got lots of little issues like the rusty RF connector, the split in the board, just little things like that, but it's working good now. I hope you enjoyed this video. You might also like this one with a psychedelic Commodore 64, or this one where a 1541 disk drive beats me up. Thanks for coming!